In this video, I'm going to go over three questions, three questions that have to do with tension. The first one's going to be easy, the next one is going to be a bit harder, and then the next one is going to be really hard. Well, let's walk through this. So, tension is a type of force that you will learn in AP Physics 1, specifically in Unit 2, right? So, this is a pretty simple tension problem and a great way to introduce physics students to tension. So we have this box that is dangling on a string that is attached to the ceiling, and this is when tension comes into play. This is what tension essentially is. It's basically the force that's measured in the string attached to the box and to the ceiling. The box's mass is 74 kilograms, and there's a force of gravity, and the net force is 0. Our job is to find T. So, like I said, the net force is 0, right? So you're going to have to think of it this way. Oh, my pen is really messed up for some reason. If the net force in the y direction is 0, forget about the x direction. There's no x directional forces happening here. But if the net force in the y direction is 0, that's because it's not moving, and it's not moving in this scenario. Even though there's a force of gravity that's technically trying to pull it down, or it's making an effort to pull it down in this case, but there's a tension force that's keeping the box in place. You can derive an equation here. You may not even need to do the math here to figure out that the tension is equal to the force of gravity. We already know how to solve for the force of gravity. mg 74 times 9.8. That's a really bad 8. I don't know why my pen is lagging so much. But then you can just plug this all into your calculator. 74 times 9.8. That gives you 752.2 newtons. Why is this lagging so much? And remember, our tension is equal to our force of gravity, as we discussed earlier. So our tension is pretty much 752.2 newtons. Now let me, in case you're already confused here, let me just reiterate. So the reason these two are equal to each other is because the net force in the y direction is 0, right? So it's not moving up or down, which basically means that the forces that are acting in the y direction are equal and opposite. So basically what that means is that the tension force that's making an effort to, or is responsible for keeping the box up, is equal but opposite of the force of gravity that is pulling it, that is making an effort to pull it down. So these two are equal. And you can also figure this out by setting up your F net y equation, which is equal to 0, and you just list the forces in the positive direction and the forces in the negative direction. So in this problem, we're kind of given a very similar scenario here, except we have two tensions that are pulling the box up, or responsible for keeping the box up, and resisting the force of gravity. Again, the net force in the y direction in this problem is equal to 0. Now what we need to do here, set up our equation. Well, we have T1 plus T2, because these are positive forces in the y direction. Then we have Fg, which is negative. My pen is so laggy today. Add Fg on both sides, and you're left with this equation. Fg is equal to the first tension plus the second tension. Now you might be a little confused here, but the thing that you need to realize first is that the length of tension 1, the length of the rope of tension 1 is the same length of the rope as the rope of tension 2. So what that basically means is that tension 1 is equal to tension 2 because they're the same length. Right? So because they're equal, the amount of tension in tension 1 and 2 is basically going to be half of this number. So you can pretty much just divide it by 2. My pen is way too laggy. I apologize. You get 362.6 Newton. Now, granted, if the lengths of these two were different and were not the same, then we would get different values for each one, right? Because one tension would be a bigger contributor to keeping the box up than the other tension, right? It's all conceptual. Understanding physics conceptually is key. You can't just know the math. Otherwise, it would be much easier since this is all just algebra. You need to understand it conceptually. Alright, now moving on to the really hard stuff. So, already by looking at this, you can already tell, like, what the hell is this? This is a very wonky tension problem. And unfortunately, this is the kind of tension problem you're going to be dealing with in AP Physics, typically. But basically, we have these values. Oh wait, I forgot to put the angles. Hang on. So for this angle, we have 25 degrees. This angle, we have 55. And we want to know tension 1 and tension 2. Oh, and tension 3 as well. Tension 3 is by far the easiest one to figure out. You don't even need to calculate it. Tension 3 is equal to the force of gravity. That's just what tension 3 is. Because it's equal and opposite with the force of gravity. Yeah? But then there's also these strings that are holding tension 3 in the box and everything together. So we need to figure this out. Well, we can't figure it out just yet because we haven't really delved deeper into it. We just need to unbox everything. First off, we know there's a net force in the x direction. We have, hold on, let me color code this actually. We have x directional forces over here. So let's do that first. And we know it's 0 because it's not moving. By the way, the reason this T1x is negative is because it's going to the left. Yeah? These two are positive because they're going up. They're opposing, in a way they are opposing T3. We'll get to that later. But basically you have T2x here minus T1x. My pen is super laggy. And it's very delayed. You derive this equation. And then when you move on to the y direction, this is where things get a little interesting. It's still 0 because it's not moving in either direction. But then you have this. You have T1y plus T2y minus T3. Why could this be the case? Well, remember, equal and opposite. So you derive this equation. Okay? And one thing you could do here, if you're stuck here, this is where you need to think logically. And I'll show you what that means in a minute. Okay, so we have this equation between the two tx's, right? One thing we can unravel is that t2x is equal to what? It's equal to t2 cosine 55, right? Because this is the adjacent side. And then the same thing with t1x, except with t1 and cosine 25. And what you can do here, this is where we get into variable substitution. Divide both sides, these cancel out. You end up with this equation right here. So we have a way to substitute t1. And that's what we're going to do in this equation right here. Let's go ahead and do that. Alright, so let's do some substitution here. T3 equals and then the sine of t1y is t1 sine 25. We can just write sine 25 here because this entire thing represents t1. Then we have t2 sine 55. Now this looks a bit tricky. Here's the tricky part. All you have to do, forget the t's, just evaluate cosine 55 divided by cosine 25, multiply that by sine 25, and then add that by sine 55. Just forget the t's. Just do the math. So cosine 55 divided by cosine 25, you multiply that by sine 25, and you add that by sine 55. And then you should end up after evaluating that, you should end up with 1.08, or actually, no, if we're rounding to the nearest hundredth, 1.09 T2. And then we already know what T3 equals, because T3 equals 725.2 Newton, right? It's equal to the force of gravity. All you have to do now, simple algebra. Divide on both sides. You end up with 725.2 divided by 1.09. You end up with 665.3 Newton for your second tension. So you solve for your second tension, which now means that you can solve for your first tension because you know what T2 is, and we need T2 to solve for T1. Alright. So let's do this. 665.3 cosine 55 divided by cosine 25. Just plug that into your calculator. Then if you're fortunate enough, you should get this as your answer. 421.04 Newton for your T1.